Welcome. This is Prof. Nanius. What I'm going to do is I'm going to give a short video about an alternative way of doing a problem that's typically done by integration by parts. So we'll go to share screen and I'll pull up Paint and we'll get started. Okay, time now. Okay. But yeah, I had something else I was doing. Here we go. So let's go ahead and start. Now, I'll go ahead and do my line size here. Now, this is a typical kind of integral. Suppose you like to do this integral here. Integral, let's say of e to the 3x sine to the 5x, sine of 5x dx. Now, this is typically done by in calculus classes by integration by parts, but we can use something at our disposal, and we can use Euler's formula. And Euler's formula says that e to the ix is cosine of x plus I sine of x. Okay, so what does that mean? Well, it means that my stupid computer wants to give me updates when I don't want them. Well, let's go ahead. Now, what does that have to do with this? Well, notice this is a real part. The sign appears here. So if I decide to write this as E, E, and then what I'm going to do is I'm going to write an X, and then I put my parentheses here, 3 plus, in this case, 5i. That turns into e to the 3x times e to the 5ix, which turns out to be e to the 3x plus, well, let's get rid of that, times, of course, cosine, 3x, right? Cosine of 5x plus I sine 5x. And doing a little bit of algebra, plus e to the 3x times I sine 5x. Now I'm going to go ahead and do this, put this in red here. And notice this is what we're trying to integrate except without the I. Okay, so this is exactly what we're trying to integrate. So what's it have to do with our problem? Well, what this basically tells us, I'll go back to 100%, is that this tells us back here, oops, forget the back here, and I'll just go ahead and leave it at red. This tells us, darn it, this is not what I wanted. Still a rookie. I'll just undo this. It's not what I wanted again. Failing here. Okay. This tells us that we can solve our integral by integrating the integral of e, in this case, to the 3 plus 5i x, and taking the imaginary part. No integration by parts needed to do this. So let's go ahead and just do it this way. So scrolling up and scrolling this way a little bit. So let's get started. So now let's just change colors just to change colors. And so if I want to integrate e to this case x 3 plus 5i dx, you can do this just like a regular calculus integral of e to the ax. Divided by that constant. Okay, that's a pretty easy interval, right? But what does this equal? Because remember, we have to now use Euler's formula. So we have this. And then up top, we have e to the 3x. And using Euler's formula, cosine of 5x plus I sine 5x plus c. Now, we're not quite done yet because we still need to get the real answer. And we also have this imaginary constant right here that we have to deal with. And notice we have a 5i in the denominator. So the way you actually deal with that is if you have something plus something I, you multiply top and bottom by something minus that something I. It's called the complex conjugate. So if I take this thing here, minus 5i, you just change the sign of what that is. Like so. Then you multiply through. Look what happens on the bottom. On the bottom, you get, by design, you get a 9, 3 times 3, minus 15i, plus 15i, they cancel. And 5 times 5 is 25. I times I is -1 times -1, so you get this, plus 25. Up the top, you get 3 minus 5i. And then we get e to the 3x cosine of 5x plus I sine of 5x. Okay. Now we're almost done because you do have to do a little bit of arithmetic right here. So let's just take this stuff on the denominator. I believe that's 34. Then you have to multiply this. So here's what happens. You multiply 3, you get 3 cosine 5x. Then you get plus 3i sine 5x. I'm going to go ahead and just scroll down here. Then you got to do the 5i minus 5i cosine 5x. And then minus 5i times an I is going to be plus 5. So the imaginary part will be basically everything that has an I. So it'd be 1 over 34 e to the 3x. Then we have the 3 sine 5x minus 5 cosine 5x. Want to just do a quick double check. Yeah. Plus c, of course. And that gives you the integral of, it gives you the required integral there. E to the 3x times sine of 5x. Now, in case you're somewhat skeptical, let's just go ahead and just do an online integrator. And let's just remember what our thing was. That's not what I wanted. Paint e to 3x sine 5x. So let's just go. So we get there's your 34, there's your 3, and there's your 5, as we said. There's your 3, there's your, and there's your negative 5, and there's your 34 in the denominator. So in fact, now my, now this little thing right here, you might have said, okay, well, it took some time. Wouldn't it have just been quicker to do it by parts? Well, let's just go ahead and to show you the utility of this. Let's just go ahead and do a problem from scratch using this method, but without all the explanation. So let's say, let's just turn to green here. And let's go ahead and suppose you wanted to do with the integral of, let's say, e to the 2x cosine 7x. Then what we do is we instead do this. We look at the integral of e to the x 2 plus 7i. And we look at the real part of our answer. This, of course, the integration is a piece of cake. There's our answer. And then we want the real part of this. So the real part is we write this as 1 over 2 plus 7i. We're going to have to resolve that, so we'll multiply it by 2 minus 7i, like so. We have to do the top and bottom so we don't change the answer. We have e to the 2x, and then we have cosine 7x plus I sine 7x plus c. Can't forget the c, that's always important. And let's just scroll this down a little bit this way. So we have that. Well, actually, so let's just write this up here. This is all equal to, up top, 2 minus 7i. The bottom, Well, 2 times 2 is 4. And you're really just summing the squares. 4 plus 49, because the stuff with the I is going to cancel by design. And then we have e to the 2x. And then we have cosine of 7x plus I sine 7x plus c. Then when we do the multiplication, it's 1 over 53, e to the 2x. So then we have a 2 cosine 7x. And then we have a minus 7 times an I is, I times I is negative 1. Negative 1 times negative 1 is 1. So it's going to be plus 7 cosine. Screwed that up. Let's erase that. That's going to be a sign there, of course. And to make mistakes sometimes. So let's see here. Go back to our line. And it's going to be 7 sine. Let's see. Yeah, 7 sine 7x plus c. And I'll just try to box in our answer because I probably have, well, there you go. That's it right there. So you see, I think this goes quicker than doing integration by parts. So thanks for watching.